Hello guys, myself Professor Dimple Chalisajar, working in one of the leading universities, federal government universities in United States of America. And today we are going to start the new course that is based on statistical, elementary statistics. And I would like to upload the complete course over here on YouTube. So today is our first class. So let me share my screen with you guys. Can you see my screen?
Yes.
Yeah, so this is the book we are going to refer throughout this course. And the title is Probability and Statistics for Engineers and Scientists. So those who are STEM major, this book is highly useful to them. Excellent book, nice examples, nice explanation. All these things are given in details. And we are going to cover lots of things from this book. And let me just give you a brief outline about this one. So first of all, there are several chapters in this book. And I just would like to let you know, this is the 9th edition, very latest edition. The content of the book is like this. Usually people say this is Myers and Myers book. These 3-4 authors are there, Radford University, Virginia Tech, here in Virginia. And this is the content. First chapter that is based on the introduction to statistics and the data analysis. 7 articles are there. We will look at all these articles one by one. And the second one, that is the probability, in which we are going to see some sample space, events, then continuing sample points, probability of an event, additive, some rules, additive, multiplicative rules, something like that, and Bayes theorem. Once we are done with chapter 1 and 2, usually I prefer you guys to go for the first exam, because here in United States, usually we have that pattern. I offer 3 internal exams and 1 final exam. And I usually design this syllabus in such a way that you can take a first exam, first internal test after first and second chapter, after second chapter. Then after, I would like to go for chapter 3, 4, 5, and 6 together for your second test syllabus. And chapter 3, that is based on random variables in the probability distributions. Chapter 4, that is the mathematical expectations. Everything that is based on expectation over here, and some discrete probability distributions, that is chapter 5. And chapter 6, that is based on the continuous probability distribution. So discrete probability distribution and continuous probability distribution, these 2 types of distribution, probability distributions, we are going to see in these 2 chapters. And once we are done with chapter 6, then after, you guys can take your second exam, second internal exams. Chapter 7 is quite easy. It's a function of, say, function of random variables, but that's the optional you can see over here. Those who are STEM major, I mean to say science major as well as science, I mean to say that biology, botany, chemistry, physics, etc., and engineering major. So that is called STEM major. Engineering includes all the disciplines like electrical and computer science, civil engineering, mechanical engineering, IT, everything, chemical engineering. So for all STEM majors, this course is really very highly useful. Chapter 7, that is not that useful. Of course it is useful, but we are just 3 articles are there. We are not going to see these 3 articles, but we will jump over to chapter 8. So chapter 8, that is based on the fundamental sampling distributions and the data description. And then after, we are going to see chapter 9, that is 1 and 2 sample estimations problems. Then the chapter 1 and 2 sample estimation problems. We are not going to go over each and every article of the chapter. We are going to, I have picked up some of the articles which are highly useful in first STEM majors. So maybe we can go over 9.1 to probably 9.10, 9.11 like this, but not all the articles. So those who are not that important for the STEM majors, I have skipped some of the articles, but they are just in a similar way than the previous articles. So that's not a big deal. And then after the last chapter is actually the second last chapter, that is the 1 and 2 sample test of hypothesis. So 1 sample test and 2 sample test of hypothesis. We are going to see. Once we are done with chapters 8, 9, and 10, I usually offer third internal exam. And then after last 2-3 classes, usually I have, in which I just would like to go over a few of the articles from chapter 11. There's the linear regressions and the correlations. So we can go over a few of the articles of this one, and that will be the end of the syllabus. And then after, one can go for the final exam. So that's how the syllabus is defined. So this is just up to chapter 11. There are a few more chapters, chapter 11, 12, 13, 14, 15, you can see over here, but that is not included for this particular course because that is extremely difficult to go over all the chapters just within certain time period. And I would like to upload all these videos for you guys as far as concern of chapter 1 to 11, I would say, except chapter 7, or we can include that one, we'll decide. So that's how this one is designed. And some introduction portion is there. And the first chapter that is based on the introduction to statistics and the data analysis. Very nice introduction part is given over here. If somebody is interested, he or she can go through each and every line of this one. And that gives you really more information. I don't have time to go over each and every line, but I will give you a brief outline in the introduction as well as the variability in the scientific data and everything. And let me now start. I have prepared some slides so for you guys. So I think we can go over those part. So let's start with chapter 1. All of our videos, let me just let you know these things, that all of our videos, that will be a very short videos, 40 to 45 minutes, mostly 40 minutes. So that I don't want you guys to get bored. And that's why I just would like to restrict myself to 40 minutes. So that whenever you want to look at this one, at that time, you can just spend 40 minutes and try to have some knowledge. Let's start with this one, chapter 1, Introduction to Statistics and the Data Analysis. Very introductory chapter is there. So whenever it is required to write something at that time, I'm going to use the whiteboard. But right now for these first 2 slides, probably it's the first 2 lectures, we don't require any whiteboard. But whenever it is required, definitely we'll go over that one too. Okay, let's start. So here the learning objectives are a random variable and its types. That's what we are going to see first. Then what we mean by the population in the samples. Just keep in mind this thing that sample is nothing but the subset of the population. I will explain to you, giving you some practical examples. Then after simple random samplings, types of statistical studies, measure of centers. Measure of centers, I mean to say that you can find mean, median, all these things. So measure of centers, compare some of them. And then after we are going to see measure of spreads, means standard deviation and variance. That is called measure of spreads. And the shape of distribution, the visual tools, you know, different shapes are there, right skewed, left skewed, normal distributions, all these things we are going to see in this chapter. So it's just the elementary things, or those who have gone through some of their basic statistics course in 11th, 12th grade. For them, I think it's a kind of revision. So let's start with the first one. You can find some funny things over here. The first one, there are 3 kinds of lies, damn lies, and statistics. That's what Disraeli, he said this thing. There are 3. So statistics is not the exact thing. That's what he means actually.
Okay.
Approximation. It's approximation. You can judge, you can take some decision having some information. And that is why the probability is the most important thing, that usually in our real life problem, we say that what we mean by the probability. What is the probability of to win this game? What is the probability to win the lottery? What is the probability of getting or done with this work? What is the probability of securing A grade in this course? Something like that. So always we are looking for, knowingly or unknowingly, we are very much habituated to use this thing, that what is the probability? What is the probability of several things? So it itself says that we are not looking for exactly. That means nobody can predict this thing, that I'm going to get exactly 95.231 percentile or percentage in this course by the end of the semester. No, you can't predict. It could be 95, it could be 96, 94, it could be anything. You cannot predict the future. You can have a little idea about the future. And that's what we mean by the statistics. And I think that's why B. Disraeli, whatever he said, partially I agree with him too. Anyway, it's a joke. So why study statistics? That is the first thing. So learn to think critical about the numbers, their sources, and the processes used to generate them. So it's a very layman sense. Look at over here. The definition, actually there is no definition of statistics. But if you want to teach somebody in a very layman sense, I would say that if somebody is interested in learning the critical thinking about the numbers and their sources, where the numbers are coming from, data analysis, and the processes used to generate them. How numbers are generated, what's the process, what's the real life application behind it, from where the numbers are generated. So that's what we mean by this one. Become an educated user of statistical information and make better decisions. Why statistics? To become an educated user of statistical information and make better decisions. As for example, Japanese achieved super production quality using statistical quality control. How to use data in your field. Suppose you are given some data and you are looking for something, how to make proper use of those data in your particular field. So that is the importance of statistics. That's why we want to learn statistics. So now what is statistics? Just now I told you, no unique definition. It's just, I would say, the science of data. So the question must arise, what we mean by data? What are data? So data are nothing but the observations that you or someone else records, right? Suppose somebody goes to the mountain range and try to measure the temperature, or mountain ranges at different levels. So that means you have some different data. Temperature at certain period of time in the day. So it's a data. Once we talk about the data, that means we have two options. The first one is data could be numerical, it could be non-numerical too. Numerical, that means when the numbers are involved, numbers are there, it is called numerical. It could be any number, not necessarily just the natural number. It could be any number. It could be like this 1, 2, 3, 4, 5. It could be 1.5, 1.7, 1.8, 1.9 like this, right? So that is the numbers. Just like if I have suppose 60 students in the class, and if I want to measure the weight of all the students, someone weight is suppose 165.2 pound, 150.127 pound, 145 pound, something like this. That means I cannot miss any of the numbers from the real line. And that's why these type of data are known as the continuous data. That's what we are going to learn probably today or maybe the next class. Second one is income. Income is a discrete data. Why discrete data? Of course, income, I don't say income is always the discrete data, but usually whenever your income is there, then we say that I'm earning 100,000, 110,000. Usually we don't count the cents or like this, but actually it's a continuous data too. Income, that means when you go to file your income tax, at that time you have to provide complete data. What is your income with cents? So that's why in that case you cannot ignore. So in that case, I would say that weight, income, all these things, how much money is there in your pocket, all these things, they are. Then scales from 1 to 10. Suppose you are given one question and we ask you that how much you agree with this one. Suppose you have some pain in your leg and doctor asks you, what is the pain level? What is the scale of pain in 1 to 10? And you said, I have 7, scale is 7. That means doctor will count that one as little bit more pain, which you cannot tolerate. If it is 9, that means a severe pain. Immediately one has to take the action. So like this. So these, because numbers are involved over there, and that's why these type of things are known as the numerical continuous data. Continuous numerical data. And non-numerical data, as just now I gave you the example, mountain ranges, that is of course numerical, but I would say that eye color are measured in terms of whether blue or black or brown. That's an eye color. Number is not involved here. Army rank. If I'm working in army, that means I have rank like major, lieutenant colonel, colonel, brigadier colonel, like this. So whenever we have this type of things, when numbers are non-involved, that is called non-numeric. Ethnicity, that is also the non-numeric, right?
Yes.
Gender, non-numeric. Plenty of examples are there. So data are just divided into two parts. One is numeric, whether it is numeric or it is non-numeric, that's it. And then let's see the measure of centers. One of them is standard deviation, variance, all these things. But before that, that will come later on. But right now, I just would like to explain to you what we mean by the variables. So variable is a characteristics of the people or things, like person's gender. It's a variable. A weight of a newborn puppy, variable. Concentration of carbon dioxide, CO2 in atmosphere, variable. It's not just carbon dioxide, it could be oxygen, I mean say oxygen too. Concentration of oxygen in the atmosphere, nitrogen in the atmosphere, what it may be, right? So these all are the variables. A variable is a characteristics of the people or things. Characteristics. The word variable comes from the fact that the measurements vary from data value to data value. Variables are usually denoted by the capital letters. Always keep in mind this thing throughout the course. Whenever we want to define some variable at that time, we will be using some capital letters like X or Y or capital A, capital B, like this. X, Y, they are really very easy to mention for the variable because it's very popular that variables are always denoted by the capital letters. Just keep in mind this thing, mainly X and Y. So naturally, types of variables. Just now we talk about the numbers, datas. Now I would like to attach those datas with the variables. I talked about the datas. We divided data into two parts, numerics and non-numerics. Numerical datas, they are also known as the quantitative datas. Non-numerical, that is called qualitative or categorical datas too. So numerical data, quantitative data, we already discussed about this thing, datas, but we are now going to describe the same thing in terms of variable. A numerical variable describes the quantities of the objects of interest. Again, it could be discrete or continuous because the numerical variable is defined through the data set. So weights of an infant, number of defective parts. See, number of defective parts. You cannot say 1.5 parts are defective. Suppose you have 10 screwdrivers and one is not working or two are not working. In that case, either it is 2 or 1, or you can say all are good, or 1 is defective, or 2 is defective, or 5s are defective. But you cannot say that 1.5 is defective, 2.5 are defective. You cannot say like this, right? Either it is 2 or 3. This type of data are called discrete data. Whenever only natural number is associated, I mean to say that 1, 2, 3, 4, 5, like this, natural numbers are there. But you cannot go in between 1 and 2. There are infinitely many numbers, but we are not the concern about this. We are the least concerned about it. These type of data are known as the discrete data. So discrete and continuous. Discrete, I mean to say this one. And continuous data, already I gave you the example, weight of all my students over there in the class, weight of all the people in one class, weight of one class of, I would say that of grade 10, grade 12, like this. So these are all the continuous data. Time to run mile. Suppose you want to run 1 mile. Sometimes it takes, suppose 5.1 mile, I would say 3 minutes and 2 seconds, 3 minutes, 20 seconds, 2 minutes, 59 seconds, something like that. So it's a continuous data. Right? So it could be discrete, it could be continuous. So weight of an infant, continuous. Number of defective parts, discrete. Time to run the mile, continuous. That's how you can get characterized. Categorical, qualitative variables. Now the numbers are not involved. Quantity numbers are involved. It could be discrete, continuous, but qualitative, just quality is involved. Like your skin color, right? Skin color, it could be brown, British color, it could be white, it could be black, right? Birth city, right? Birth city, that means now we are counting the name of the city. We don't count those numbers that because your birth city is just a unique number. So birth city, somebody says that it's San Francisco, New Jersey, New York City, Houston, right? It could be anything. So birth city. Last name, we are not concerned. Suppose some few people have common last name, that's fine. But these all are called the categorical data. So data values are usually words and naturally split into categories. Because it is split into categories, and that's why it is known as the categorical data. And different types of variables require different statistical methods, right? That is very obvious.
Yes.
Let me give you one example. Look at the chart. Don't look at the bottom part, just look at the chart. I would like to do something like this, if you don't mind. No, I can't do that thing. Okay, it's a slide, so that's why. But just look at the table. Don't look at below table. In table, you have age, gender, major, units, housing, and GPA. Out of this one, we would like to bifurcate this one in terms of numerical data or numerical variable and the categorical variable. Numerical means numbers are involved. How many, in which columns you can find numbers? In the first column, age, then you can see fourth column, units. You can see the last column, GPA, where numbers are involved. In age and units, numbers are given 16, 15, 16, 18, 20, 20, 21, means natural numbers. So discrete numbers, right? So numericals. And GPA could be anything, 3.62, 3.125, right? So it's a continuous data. So, but ultimately, they are the data, means it's a numericals. So age, units, and GPA, they are numericals, and categorical data where categories are there, not the numbers, like gender, male or female, I told you, majors, psychology major, engineering major, physics, chemistry major, nursing major, business major, like this. So it's a category. Housing, dorm, parents, right? Apartments. So here we are talking about some category, and that's why it is called the categorical data. Population versus sample. If you remember, please try to pick up my words, guys.
Okay.
Initially, I told you that samples are the subset of population. I would like to explain to you all these things in detail, giving you some practical example. First of all, let's go through the definition, and then after I will give you the example. A population, the population is the collection of all data values. Information about the population is usually the goal. However, obtaining all data values from the population is usually impossible. Look at here. Obtaining all data values of the population is usually impossible. You must be wondering why I wrote it down like this. Why can't we be able to get all the data values of the population? Or it's very costly. Why? Wait, I'll let you know. Second, the sample is a subset of population. A sample is subset, I told you. It's just a part of population. Sample is used to get a partial understanding of the population. Partial understanding. Intentionally, I put this word, partial understanding of the population. Let's try to understand these two definitions first. Let me give you one example. Just now, before a couple of months, we are done with the election process. And I'm not favoring any of these parties. Please don't involve me in this type of politics. But I just would like to consider this one to let you know the difference between the population and the sample. Let's go back 1 year. I mean to say 8 months or 1 year back. When Republican and Democrats, they both were trying to win the election that was held on 8th of November. You know these things in United States. And before that, before 6 months, 8 months, before a year, the campaigning that was started. Now, it's not possible for any of these parties, whether it is Republican or Democrats, to contact each and every people, each and every public staying in the United States, those who are eligible to vote. Roughly, I would say, I don't have exact data, but roughly I would say, suppose 35 million people are eligible to vote. Now it is not possible for any of these two parties or media people to reach to all these 35 million people, those who are eligible to vote. But these 35 people are going to vote in the election. So you cannot ignore them. Are you getting me?
Yes.
Means these 35 million people, those who are eligible to vote, that is nothing but your population. This is the total. Of course, there are some other people, but they are not eligible to vote. So that's why we don't have to count. We don't count them. We don't have to, right? We don't count them. Because election process that is mainly based on the voters, those who are eligible to vote. Now, as I told you that you cannot go to all the cities of the country, all the states, all the counties. That's absolutely impossible. It's time consuming and you can't predict anything based on that one. So what we are going to do, we can base something like this. Suppose I am here in Virginia. Let's talk about the Northern Virginia. Northern Virginia, there are different counties, Fairfax County, Alexandria, different counties are there. We are not going to contact all the people staying over there in Alexandria, those who are eligible to vote, but we are going to go to one common place and we can pick some of them. Suppose I go to the school, I go to one college. In Fairfax area, there is George Mason, one college is there. Means if students are there in college, that means they are above 18, eligible to vote. And in the college, in the university, I can pick few of the students from science major, few of the students from engineering major, few of the students from business, few of the students from economics major, like this. So I can find few, means it's not necessarily that all should be equal number, that 10 students from the physics or 10 students from engineering. No, suppose 50 from engineering, 40 from science stream, then 45 from other streams, like this. And then we ask, this is just the subgroup. See, there are actually, now let me just go in a little bit more depth of this problem. Total capacity of the university is, suppose, I don't know exactly, but suppose it is 20,000. Out of this 20,000, I have made some groups. One is the group in which I have 50, or I would say 500, or I would say 50 from the engineering section, 50 from the other section, 50. This way I can make 10 groups. 10 groups of 50 means it's just 500 people. So I am not going to ask all 20,000 students, or out of this 20,000, suppose 18,000 are eligible to vote. So I'm not going to collect or ask or approach all these 18,000 students, but instead of that, I'm going to ask only these groups. What is your choice for the next election? Are you favoring Republican or are you favoring Democrats? And people are sometimes really very honest. They say, no, we like this one. I'm not going to argue with them why you are favoring this or that. No, my question is very simple question. What is your choice for the next election? Some people say Democrat, some people say Republican, and that's it. This way, this is called the sample. Sample is a subgroup. Because I have chosen those 10 groups, 500 students, just from the university. University is my population now. I'm not counting all the universities, but I'm counting just these groups, just 10 groups. That's the sample. And I take the survey of these 10 groups, 500 people, samples. Based on their analysis, suppose out of these 500, I am getting almost 350 people, 350 students. They said that this time, suppose, it's just the example, please don't take it personal. Suppose they said that we are in favor of Democrats. And the rest of the 150 students, they said that no, we are in favor of Republicans. So my general conclusion based on only these groups, that is that Fairfax County, or at least George Mason's students, or the Fairfax County, these guys mainly going to vote for Democrats. Same way I can go to the nearby, suppose some church. Now, all the people are not going to the church. Some of them, they come to the church. And once their prayer and everything is done on Sunday morning, I just stay outside and I just ask them about their opinion, what they are going to do. And if because varieties of people are there in church. And if I am getting, suppose there are 500, 600 people are there in a church, and out of this 600, suppose 350, 400 people say that we are going to favor Republican. And that means 200, they are in favor of Democrats. So my general attitude, that is something like this, that now this particular region, this county will go for Republican. So George Mason Fairfax, that is one county. People, they say that we are looking for, or we are in favor of Democrats. Then after I went to another county, I made a group, samples. I asked them, I come to the conclusion that these people are going to go for the Republicans. There are several counties. Suppose we have 20 counties. Or suppose not 20, 20 is less number, but suppose we have 40 counties in one state. In Virginia, suppose we have 40 counties. In these 40 counties, this type of groups I've made. And then after, I'm going to make the analysis that out of these 40 counties, almost 32 county people, they are in favor of Democrats. 18, they are in favor of Republicans. So by general attitude, general conclusion, that would be like this, that Virginia will go for Democrats. That's how this election poll or exit poll decisions are being taken. So that's what we mean by the population and the sample. Then after, let's go for the different types of sampling methods. One is simple random samples. Every subject of population has equal chance of being selected or being take part in the event or being sampled, you can say. Taking part in the event means samples. So that is called the simple random sampling method. Just now I told you that all the people of that George Mason University are eligible to vote. Suppose that means all have equal chance of being selected as a sample. But we chose just few of them, just because of our convenience. So simple random, that is, we count the whole population. So usually that method is not that appropriate. Another methods are convincing samples, stratified samples when the numbers are involved, random samples, all these things. I think the sampling method in detail, I will let you know probably in the next class. Let's go ahead. Then the samples, look at the example. Detail in samplings, I will let you know in the next class, as I told you. The sample 10 students randomly versus 10 sitting in the first row. See, very simple example. 10 students are there versus 10 sitting in the first rows to estimate average IQ in the class. How does this affect the interpretation of the result? Right? 10 students are there versus 10 sittings in the first rows to estimate the average IQ in the class. 10 students are there, 10 seats are there, average IQ in the class. So who will occupy the first seat, second seat, third seat, like this. So that is just called the simple. This is the best example of simple random samples. Okay. Experimental. So types of statistical studies. Experimental and observational. Consciously split subjects in the sample into groups and record the differences to infer cause and effect relationship between the variables. As for example, they randomly split people into two groups. One takes vitamin C, another does not. Observe flu occurrence, right? We have one section. In that section, suppose we made two groups. One people, we provide vitamin C tablets. Another group, we don't provide any vitamin. And then after in the winter, we just try to measure how many people are affected from flu virus from both groups. Usually, experimental data says that the group members, those who are taking vitamin C, they are less affected by flu virus than the other group. So that is the experimental data. We made the experiment on two groups. Second one, that is observational. Subjects are found in pre-established groups. Researchers observe the differences. So subjects are found. First, you made the groups, and then after pre-established groups are already made. And then after you can pick the subjects from that pre-established groups. So that is called the observational. Like pre-established groups means now we can see this thing in a larger way. Look at the example. Koreans have a substantially higher rate of gastric cancer than the Americans. They also eat more kimchi. Can one conclude that kimchi increases the chances of developing gastric cancer? Right? There are a couple examples are there. Example 1.2 and 1.7 in the exercise. I just would like to go through the example 1.2. And don't use, see, I just made the red highlighted things. Don't use the observational study to establish the cause and effect relation. Don't use this thing. Don't use the observational study to establish a cause and effect relation. Okay, let's go through this example 1.2. And then after, if time permits, let's go through a little bit more. So let me go through example 1.2 from the book. Example 1.2 says something like this. Look at here, guys. Let me just highlight this one. Often, what you want to say, the nature of the scientific study will dictate the role that probability and deductive reasoning play in the statistics inference. Forget about these numbers. The page, some data are there associated with the study conducted at the Virginia Polytechnic Institute and the State University, that is called Virginia Tech over here in Virginia, on the development of the relationship between the roots of the trees and the axon on a fungus. Minerals are transferred from the fungus to the trees and the sugars from the trees to the fungus. 2 samples of 10 northern red rock seedlings were planted in a greenhouse. One containing seedlings treated with the nitrogen and second one that is without nitrogen. Look at here. Seedlings with no nitrogen, means without nitrogen. Right, guys?
Sir,
yes.
We cannot see your page. That
Oh, you cannot?
are...
Okay, I'm sorry. I'm so sorry. Can you see now?
Yes.
Oh, I'm sorry. Let me just go back. It won't take much time. Look at here. Often the nature of the scientific study will dictate the role of the probabilities deductive reasoning play in the statistical inference. And that's what I just explained to you.
Okay.
We have 2 things. One containing the seedling treated with the nitrogen, and second one, other that's containing seedlings with no nitrogen. All other environmental conditions are held constant. We don't count other environmental conditions because I know that environmental conditions, they play a big role over here, but just for the sake of convenience, let me just skip that part. All seedlings containing the fungus that is given over here, Physolithus tinctorus, just forget it, it's just the name of the fungus. We are not concerned about it. More details are supplied. We are going to see this thing in detail in chapter 9. Guys, please keep in mind this thing. Whenever I take some examples, that means don't think that I'm taking that example randomly. Mostly the illustrative examples which I'm going to take, those examples you will find very frequently in our subsequent chapters. So please keep in mind this thing that once we have one example, because I'm not going to take all the examples from the illustration. I'm going to take some of the examples from that. And once I take that example, that means just keep in mind this thing that it has its own importance for the further study. The stem weights in gram. Now the stem weights are given over here. The no nitrogen and another is the nitrogen. Look at over here. The nitrogen that is given by no nitrogen that is given over here and nitrogen is given over here. And I have this chart over here, dot plot chart over here, 0.25. Based on this one, we just make standard partitions, 0.25, 0.30, 35, 40, 45, 50, 55, like this up to 90, because our numbers, they are between 0.25 to 0.9. So that's why I took like this. And then after 0.32, so I just put it over here, 0.32 you can see over here. So this no nitrogen that I denote by X, or you can say cross. And nitrogen I do not by O, or you can say circle. So
okay.
Mind this thing. So once you have suppose 0.32, so 0.32 stands over here. Look at my cursor. Can you see my cursor?
Yes.
Yeah, so that is my cursor. You can see here. And then after, suppose I want to go for nitrogen. So 0.26, 0.26, that's very nearer over here to 0.25 on right side. So you can see my circle over here, 0.26, right? Then after one of the numbers you can find, suppose 0.28 over here for no nitrogen. 0.28, that is just side to 0.26, so that is over here. Look at here. So that's how I plot the graph on the line. So dot plot, that is called the dot plot for the stem weight data. And now you can see here, in this example, there are two samples from the two separation populations. The purpose of the experiment is to determine if the use of nitrogen has an influence on the growth of the roots or not. The study is a comparative study, and it is instructive to plot the data as shown in the dot plot, this figure, whatever I give it to you. As I told you that O or 0 values represent the nitrogen data and the X value represent the no nitrogen data. That just now I told you this thing. And notice that the general appearance of the data might suggest to the reader that on average, the use of nitrogen increases the stem weight. So if nitrogen use is there, then the stem weight is increased. That is the general data, then general analysis. So that's how you can use the data to predict something. For nitrogen, let me just keep my cursor. Okay, that makes sense. So for nitrogen observation are considerably larger than any of the no nitrogen observations, and most of the nitrogen observations appear to be below the center of the data. Below the center, you can see this is my center almost, and most of the observations, they are below the center of the data. Look at over here. Most of my data, they are over here.
Okay.
So they are below the center of the data. But how can these be quantified? Right? We know that the appearance of the data set would seem to indicate the nitrogen is effective. Look at here, nitrogen is effective. That makes sense, yeah. But the question is, how can it be quantified? How can all the apparent visual evidence be summarized in some sense? As in the preceding exam, just forget it. The fundamentals, we don't want that thing. But this type of questions can be answered using the statistics, and that's what we want. So that's why I took this example. And we are going to learn this. We are going to get whatever the questions arise over here, we are going to answer these questions in our subsequent study, maybe in the second chapter or same chapter later part. So there's the reason. Now let me just again stop sharing this one and let me go back again to my slideshow. Can you see my slides?
Yes.
Okay. Another example, you can see over here, the variables are, now first of all, try to look at the right sides. Right side, I have one chart. That is the birth data from North Carolina in 2004. Weights of the birth data. Birth data means newborn babies. How many babies are there? 1, 2, 3, 4, 5, and 6. 6 babies are there. So that is my variable, a population, right? All babies born in North Carolina in 2004 or 14, what it may be, that is my population. 6 babies. All the babies, they are the population. Or actually, I'm sorry. All the babies born in 2004 in North Carolina, that is my population. Out of this, all the newborn baby, I have selected only this 6. So this 6 is actually my sample. I'm sorry. So all the babies born, newborn babies in 2004 in North Carolina state, that is my population. Out of those population, I just counted the 6. I just picked up the 6. That is my sample. Because these 6, they are from the group of all the newborn babies. So population is all the babies in North Carolina in 2004. Sample is these 6 babies. What type of study you think the data comes from? We denote sample observation using the letter case X1. Sample observation. See, variables are denoted by capital letters, capital X, capital Y, or capital X1, X2, X3 like this. Samples are just small letters. So small X1, X2, X3, where N is just N belongs to a set of natural numbers. So out of this one, gender, male, female like this, smoke or non-smoke like this. So variables, these are the variables, gender, whether it is male or female, then weight, then mother smoked or not. If suppose this newborn girl, right? And mom is smoking or non-smoking like this. So 0 non-smoking, 1 smoking like this. So that's how you can bifurcate the given data in terms of variables, population, and samples. That's actually what I would like to let you know. And then after, you can see the fundamental relationship between the probability and the inferential statistics. You can, from using probability, you can go from population to samples, and using statistical inference, you can go from sample to population. So use samples evidence and probability theory to make inference about the population parameters. And then after, I would like to go for the next section. There is a measure of location centers, the sample mean and the median. Mean. Suppose that the observation in a sample that is given by samples means, as I told you, small letters x1 to xn, and the sample mean that is given by x bar. Throughout this book, sample mean we will denote by x bar. X bar is nothing but summation of xi by n. That means whatever the numbers are given to you, whatever data are given to you, 1, 2, 3, 4. Suppose 10 data are there. Out of these 10 data, and how many 10 data are there? So your n equal to 10. Data number 1, suppose 7, 10, 20, 13, 14, 16, 27, 29, 35, 49. I add all these data and divide by number of data. So I add all these data, divide by number of data, whatever the answer I'm going to get, that is my sample mean. That is my sample mean. We will solve the examples in the next class. First of all, let me give you a little idea about this mean and median. What are the advantages? What are the disadvantages? Advantage includes all observations. Advantage of mean. It includes all the observation. It is easy to compute. It has nice mathematical properties. And disadvantage is very sensitive to outliers. Very sensitive to outliers. Suppose in my first test, suppose I have 30 students in the class. In my first test, 28 students, they got A and B. But 2 students, they are really very poor and they failed. They are below D. That means whenever we are going to count the mean of this first test result of my class, I don't want to count those 2 students, because if I count those 2 students, my mean value will be way lower than the class average. Mean is kind of average, which is not fair. And that's why at that time, whatever is not in the data combinations, data size, just like your nitrogen, non-nitrogen portion, mostly the chart was on the left side, but there are some nitrogen portion on the right side. Right? So whenever your numbers are lying way away from your data set at that time, that is called the outliers. That is called the outliers, and we don't count it. That's a disadvantage, sensitive to outliers. Once you count that one, your mean average will go immediately, drastically, it will go down or it will go up. So that's why at that time, we don't count that part. That's what we mean by the outliers too. You're right? I give you that example. So if you want to count the class average, if you want to count the mean of the class of the first test, at that time, we just try to get the scores of all the students except those 2 students, those who got less than D, right? Because anyhow, they are not going to clear that course because they are not working hard. They are not paying attention. Something is wrong. So we don't want to count those guys. Just keep them away. Again, the same thing, exactly same chart I took it over here. My nitrogen, non-nitrogen chart, took it over here, exactly same chart. And my mean value, whatever the numbers are there, I counted all the numbers and my mean value is over here, 0.565. Always keep in mind this thing, that mean value and median, I'm going to let you know how to count median. Mean and median, they are really close to each other. If the difference is really more, that means something is wrong. It has to be really close to each other. Mean and median, and that makes a big, good statistical analysis. Good statistical analysis. And the second one is sample median and the measure of center. Sample median, you can see this is the definition. When n is odd, we are going to say, suppose n equal to 15, odd number. 15 plus 1 is 16, 16 divided by 2, 8. So we are going to get 8. If n is even, suppose 12, 12 by 2 is 6, 12 by 2 is 6 plus 1, add plus 1 later on. So 6 plus 6 plus 1 is 7. So x6 and x7. So you are going to take the average of x6 and x7. Look at over here. I will let you know all these things using the examples next time. This is just the definition. Advantage of this one is resistance to outliers. See, it resists outliers. Easy to compute, and disadvantage is needs short data, not a mathematical tractable as the mean. And you can see here, and the loss of information. That is the disadvantage. So I think, guys, let me stop over here and we will do this thing next time. Thank you so much, guys. And please keep your eyes open for the next slides. I mean, say next lecture. We will go from this point in our next class. Thank you, guys. There is no homework for today, but when the homeworks are there at that time, also I will let you know which examples are there for the homework. I will let you know everything. Thank you.
Thank you, sir.